So 5.101 asks, what's wrong about the phrase 4 molecules of NaCl? The problem with that phrase is that a molecule, by definition, is a group of atoms sharing electrons. So that would involve atoms that have covalent bonds between them. But when I have NaCl, I have a metal and a nonmetal. So I anticipate that they will be charged in order to complete their noble gas configurations. And so that is not a molecule. Ionic compounds that don't involve any shared electron pairs are non-molecules. So once I identify that one of my elements is a metal, I try to predict its charge based on giving it the same number of electrons as a noble gas. Right? So sodium would normally have 1 valence electron, and chlorine would normally have 7 if it were neutral. So if they're both neutral. So that's not how they're found naturally. Naturally, they're already found with charges. But if I'm trying to predict what the charges are, I might start with the neutral atom and try to see how many electrons it needs to gain or lose to make the same number as a noble gas to be stable. So you might incorrectly start to think that maybe the sodium will put its electron here and get next to the chlorine, and the chlorine's electron will be here, and they might start to share. Why won't they share? Yeah, so one reason is there's a big difference in electronegativity and electron affinity, meaning that the chlorine attracts the electrons. If they were to share, the chlorine's attraction for those electrons is much higher than sodium. But that's maybe a bit of a secondary reason. The primary reason is because the noble gas configuration. If they were to share, then how many electrons does sodium have? It has 2 electrons in the third energy level. 2 electrons in the third energy level is the same number of electrons as magnesium. It's not the same number of electrons as a noble gas, so it doesn't want to share. So instead, the sodium will just exist without those electrons. It won't share them. Without any electrons in the third energy level, that's the same number of electrons as neon. So now it has a neon noble gas configuration, and chlorine will keep the electrons, so that chlorine will have the same number as argon. So I can get noble gas configurations only when they don't share. So I know they won't be sharing. And if the sodium doesn't have that 1 electron it started with, then it'll have a positive charge. The chlorine will have a negative. So when I can recognize a metal and a non-metal, I should think about that type of analysis. What charge will they have? What charge do they need to be stable? And when I recognize that the elements are charged as ions, they will form an ionic bond, and that's not a molecule. A molecule is a group of atoms sharing electrons through covalent bonds. So that's really just that question. 5.101 is about making sure you understand what the definition of a molecule is, and you apply it and use it in situations where you have shared electron pairs, not ions.